Me here today or tonight on my end. Don't know what it's looking like on your end. But in any case, tonight, in a little live video, I wanted to go through some things that I was investigating with you folks and show you folks some interesting ways that you can research things, or just through me, you can live some of the research and take a little peek at some sequences. And we're going to be using something called the Online Encyclopedia of Integer Sequences, which is an amazing resource, one of my favorite websites of all time. And this live stream is partially just about that, a love letter to this website. But in particular, I was looking at the different keyword categories that they had, and I was having a lot of interesting fun combining these and seeing which of these keywords mixed together to make which sequences, and just finding all sorts of sequences in general. They have an absurd amount of sequences on here. You'd have to dedicate most of your life to read all of them. And here, the main type I put on the title that I figured would be extra intriguing to read through. We're not going to be able to do all of them. There's 179. But the ones that they call core, which they label as meaning a fundamental sequence. I found it quite interesting that the people who are like the mathematical community sort of agrees that this is the authority for integer sequences. And so the, consensus sort of shows that the elected leader of where you get your integer sequences from thinks 179 of them are extra fundamental. And of course, that will just include some things like all the positive integers, probably, or maybe all the natural numbers. I don't know what they'll call that one. I think it also even just includes the even numbers. But they don't have too many that are like copies of each other. One thing they may mean by core here is that some other sequences you can build from these core sequences. But I assume they also mean that they just think they are important and are or cool. If we look at keywords like nice, which is just them saying it's an exceptionally nice sequence, there's tons. There's let's see. It's loading nice. 60. Oh, that's funny. Nice is often a joke response to the number 69, and that is at the beginning of how many results there are. But almost 7,000 things they call nice. And like the prime numbers are one of those. But if we look at the tags of the prime numbers, the keywords, we will find it also is a core sequence. No surprise, the prime numbers are quite important. For some reason, they're calling it easy, which means it's very easy to produce terms of the sequence. I don't know why they would catalog the prime numbers as that, because I guess compared to some things where you have no idea where to look what's next, the prime numbers, there are ways with brute force. If you needed to, you could check where the next prime is. So I suppose they mean that, but on a big scale pattern, that's a little debatable that they're calling it easy to catalog terms of. But maybe they mean easy for a computer using a ton of brute force. It also has changed, apparently. And I don't know when it would have changed. Maybe way back in the day when 1 was sometimes considered a prime. When was it changed? Like, oh yeah, in the 1980s, they realized 9 isn't prime. But anyway, it also has non-negative. It's that sort of sequence. And nice and core. This one was authored by Neil Sloan, who is the guy who founded this website, and so he should get a lot of credit for this cool stuff that we're able to do. I don't know how much of it he put together, or some sort of staff or volunteers or what, but this is the guy who started the whole online encyclopedia of integer sequences, also known as the OEIS. And hello to my combo lords in chat. Good to have you here from Antigua and wherever. Lovely to have you all joining me. And just to make sure for the intro, just to note, when anyone chooses to leave the stream, hopefully when it's fully done, make sure you've caught my latest main episode linked in the description, which also is about integer sequences, some of my favorites of all time. And I even noted that in the sequences there are this one called the 2 Morse sequence, or some people pronounce it 2E or 2A. But in the online encyclopedia of integer sequences, they had a note about that pronunciation, which says it's like T and then a U with an umlaut, which I'm not good at pronouncing. But apparently that they were claiming is correct, more than 2E or 2A. But that was the main sequence and many variations of it that was in the episode I covered recently. However, it led us to these other ones that were related concepts of 2 things called evil and odious numbers. And I did note those are both in the core sequences. Out of the 179, we have the 2 Morse sequence right there. And we also have these 2 connected ones, which are like the positions of zeros and ones in this one. This is a weird framing of it. Usually it's 0, 1. You can still see, most of the patterns here, but 0, 1 is the way that most people would present this, but this is sort of an alternate one that still shows many of the patterns. And it's really about the way they alternate for many of the connections. But I'm sure they have another one here that's like the other way of writing it. Yeah, for 0 version. Is this one not on their core and the other is? Where's the tags of this one? This one is also core. I guess that's so core. They put it and the 1-2 version of it, I guess, on here. And they also have evil and odious numbers. So what are the other core ones? And after that, another one, just a hint that we'll take a peek at. They also have a category called dumb that's kind of funny to go through. So we're going to go through dumb later. But first, let's just see some of the core sequences. Because, like I said, the sort of elected authority of integer sequence knowledge thinks that these are the most fundamental in some way. Now, the first one that was numbered is the number of groups of order n, which I can't fully explain yet because I have not covered group theory, but I will make an episode of that at some point. And this is a very important thing that's like the backbone of structures. And so the number of the different groups are these very important structures that relate to these numbers or these quantities in many ways. But I'll do group theory another day. Just neat to note that's their first sequence. Second sequence that was ever put on the labeling, you can tell from the labels, the Kolakowski sequence. And this one only has 1s and 2s. And what it is the length of the nth run. So like at 1, we have, or does it have an offset we have to begin? So I think it might have to begin 1, 2. But in any case, if we look at them, we can see like there's a run of how many in a row? We have 2 in a row. We have 1 in a row. Is that right? No, that doesn't seem quite right. What does this mean? The length. I've seen this one before, and I recall it has something interesting to do with how it looks or something. That's interesting. The scatter plot gives us that line. Oh, these both lines. Yeah, that makes sense, but not that useful of a graph. This one I'll have to read more about at some point to remind myself all the details. But what was there's some, yeah, this is what I was remembering. It's a fractal sequence, but in a weird way. Replace each run with its length and you get the same sequence. So 1, then 2 in a row, then 2 in a row, then 1 in a row, then 1 in a row. And that's the sequence, the amount that were in a row. So that's what they mean here, essentially. But it's a fractal sequence. And my latest episode covers some other ones that are fractal sequences. And it's something now that I've, presented the first episode I wanted to make about that topic. A topic that will return because fractal sequences are so cool. It's actually showed up twice this grade because I showed how in Pascal's triangle you can use modular arithmetic to see this 2D fractal. Although ironically, the fractal it makes is not considered two-dimensional under many standards, but what we feel like 2D means, that shape you needed to see the fractal. Whereas the one in my more recent episode is sort of a linear fractal. And some of the fractal ones, like the one in the episode, have some trait where you just keep something, or substitute something in this case, but you might, for example, just keep the terms with an even numbered index or something. Sometimes that'll give you the exact same sequence itself. If you want to play around with something really interesting, pick a first few couple random small digits, like 1, 2, 3 or something. See if you can make it fractalish, and then look up what you come up with to see if it has a name. One of my favorite things to do is be investigating some weird thing about numbers, like, okay, here's a pattern I'm going to apply. What do numbers do? Do they make a loop or what? And then look it up on here and either feel proud that it's not on here and I found something, or feel like, oh, I found the name of it, I found more knowledge, I found, a bunch of info about it, and a lot of terms calculated and stuff. So, sort of a win-win. And anyway, that's a lot on that sequence, and I do kind of just want to comb through some of these most important sequences, and some are funny. Even the 0 sequence. All zeros. This sequence, this one should practically be called on dumb, too, because it's just kind of weird to have it as a sequence, but it shows up so many places. Like, what if we wanted to say, okay, the sequence of all the natural numbers, what are the differences between each of those? It's 1 is the difference between each and the next. What are the differences between the differences? The differences between a string of 1s is a string of 0s. So this is the double differences of the natural numbers and many other things. Let's see. Divisors. We have the number of divisors. So classic, and I'm sure they're going to have other traits about divisors here. There was one I saw that I think they have things like sums of divisors. Oh yeah, here they even have the odd divisors of n. Summing the divisors has so many cool traits in number property, as well as other things like the amount of divisors. And those, I'm not surprised, I'm glad, get many appearances on the core list. And in our core list, I love seeing a sequence that I love, that I think is in general underrated. And I'm like, yes, it's getting the credit it deserves here. Like the evil and odious numbers, or some of these other ones that aren't talked about that much outside number theory, but are so cool. We have, like, look at the P's. There's a lot of cool numbers that start with P. Oh no, they're not alphabetical. They just happen to have these all in a row. But they have some of my favorites. The rep units. What I call the hyper 11s. Although hyper 11s to me can be this in any base, a generalized rep unit. We got palindromes, the palindromic numbers. It's in base 10, but it's an example. Obviously, you could do this in other bases. And when you look for big scale patterns on this, you do compare all the bases. But like you could say, any basic base will have at least 1 1 as a palindrome, because that'll represent the base number plus 1 and exist as a representation. Now, but what other palindromes line up with what quantities? Well, these are the base 10 ones, and I did make an episode long ago about palindromic numbers. Actually, one of my favorite episodes I've made, just because the topic, I don't know if there's like hardly any YouTube videos at least, or at least when I made it, hardly any YouTube videos talking about palindromic numbers. At least not enough. And we got some of the classic just number-related traits, composites, in addition to primes. We have the largest prime factor of them. We have Pascal's triangle, which they have to do in like a sort of weird line, because it's sort of more of a 2D thing. We can look at table to see it a lot better. And we have, oh, these are going to be great. You know how I was saying fractal sequences have a lot of cool ones? These ones, they don't even clarify or name. There's 4 in a row that just have fractal in parentheses. That's exciting. This is weird. I don't know why they would have non-primes, because that's just going to be 1 and the composites. I guess it's like the backbone of so many structures and shows up so many places you'd take a list of something in math that it gets here, even if it's 1 with the composite numbers. When you see something here that you're like, why is that there? It sort of means you should research it more, because, and me too. I mean, like, if I don't know exactly why they would think that's important, now it makes me want to research what structures of numbers have 1 with the composites compared to ones that don't begin with 1. So those are some neat ones. Type of number that I will cover in the future are Bernoulli numbers. This is an example. I'm only showing it now as a little example of sometimes they need to do the numerator of something and the denominator separated because they have different sorts of fractions in the list. And that's the only way of doing it. There's also some that I hope this isn't in core, because it wouldn't be core to me. Is this it? Or is this... No, this is the this is better. Numerators and denominators of the continued fraction of square root of 3 turns to this. Way better. Continued fractions, way more base independent than what I was worried it would be, which is some of these sequences have 1 keyword that is... frac was the one we were looking at, numerators and denominators, but some say this, continued frac... Oh, no, that's the good one. This one. Constant, it must stand for. A decimal expansion of a number, occasionally some other base. And so this is what I don't like. It's like 1, 4, 1. We're writing out the digits of the square root of 2 in base 10. Maybe you could find a little bit interesting there, but it's so base dependent that I prefer the ones like this where they were doing the numerator and denominator, even though it took 2, of the continued fraction. These are many things, like everything on here is either something that I'm like, I hope I have the chance to make an episode about that someday, or I'm already planning, or I already have. I've made episodes about like half of these, and it makes me so happy to see them getting their credit. And let's see what other interesting ones we have here. Well, let's look at the fractal ones. Oh, there's a lot. There are like 6 that have just fractal in parentheses. Okay. And some other classics real quick. Prime powers. Those are, primes or prime to some positive integer. And here we have this one they said was a fractal sequence. Let's see where do they have a note about that? Or maybe we just need to try and observe it. I'm not positive which way this is a fractal sequence. This is... I don't know why that one was just labeled fractal, but that's the... Oh, maybe we need the numerators and the denominators together to see the fractal. Sometimes we can get a clue by the graph. And in fact, speaking of graphs, cool category here is look. Oh, wait, it loaded. Yeah, that graph's pretty interesting. But look is a good one. Hold on, give me 1 second. Just need to check something. But I'm here still. And here we can look at this one they called fractal, but I don't know if they actually show the fractal part of it here. The fractal part of it here, well, there's a graph, but hold on. Table. The fractal part is that if we look at, I don't want to spoil all of it because I made an episode about this just earlier this grade. Look up my Pascal triangle one if you don't know. But if you look at just where the even and odd numbers are here and give the evens one color and the odds another color, something magical happens as you look at bigger and bigger stretches of it. Because it's an infinite array where each one's the sum of the 2 above it. So many cool patterns here. Pascal's triangle. Got an episode this grade, but I already have like another episode almost fully planned related to topics such as how many times a given number appears in here. Many open questions are still unknown about that as well as you get deeper down the triangle. So that one they called fractal, even though you kind of have to know the details, but they probably had it in some note. Now, these are other ones that I'm going to have to research more and present to you if they're worth it, that they said were fractal. I would have to look deeper at what is the fractal form of those. But fractal sequences sometimes have something like take every other term, every even numbered index, sometimes every third term, sometimes every pair of terms. And there is a really cool list I found elsewhere. Maybe I'll show this in another stream. There was a list somewhere on the OEIS wiki, which is like they have a section for info about the sequences. That was a list of a bunch of fractal sequences, because they do have these cool lists too. Like, look at, this is apart from keywords. These are all like crazy, like prime factorization related special numbers that, let's see, do they have stuff listed? Almost, that has no pages or media. Some things you hit dead ends, but some of these do have like lists of sequences that apply to it. Maybe not on this page, but stuff like this. It'll be like, oh no, this one doesn't actually have them on here. Sometimes you'll have lists that have the sequences on it, and there was one about fractals. I'll dig that back up another day. And let's go back to what the core sequences are. Now, if you want to scroll through these, you can type in keyword core, but then it gives you the whole info about all of them, and it would take too much scrolling and too many pages for me to do this stream. But if you look them up yourself, I recommend doing keyword core. And there's a lot of pages to go through. Luckily, they have another thing that will show up in more episodes this grade are polygonal and polyhedral and in general polytope numbers. Here we have tetrahedral numbers. And guess what we're going to see here? Last year's number. This year's number is special in another way. But I feel like most of you saw my episode about that. That one got a good amount of views. Let's see. So, a lot of cool ones here, and there's a few that I'm sort of curious about when I see them that I don't know what they mean. Trees could be referring to a lot of different things. This is the number of trees with n unlabeled nodes. And it's a diagonal of this one, a whole triangle. Here, it's a really interesting sequence. 1, 1, 1, 1, 2, 3, 6, 11. And it's like, okay, very interesting what's going on. Now, that relates to, imagine connecting dots with like lines and stuff and seeing how many ways you could attach a new dot with a connection to something. We'll get more into that another day. It relates to concepts like the massive number tree 3. But that is not this exact thing. The third term of this is 1. If we call this shrub 3 is 1. So, anyway, what is necklaces? The number of n bead, and so I love that some of these are core. They're like kind of obscure. I don't know if I've ever seen this sequence. Although, whoa, maybe I met it elsewhere, because they say in music it relates to scales and chords. But here, it's the number of n bead necklaces with 2 colors when turning over is not allowed. So you cannot flip. The flip of something is not the same as it. How many ways can you bead 2 colors back and forth? And so we could phrase that as words of strings of digits that are 0s and 1s. And so we could say like 2 colors and you can't flip. So that means 0, 1 and 1, 0 are different. So that could be 0 or 1. That could be 0, 1, 1. Wait, why is there only 3? Because if turning over is not allowed, shouldn't it be 1, 0, 0, 1, 1, 1, or 0, 0? I must be missing something, because that would be a much more obvious pattern. Let's see. I'll have to look more into this later. Sounds pretty cool. That's apparently one of the core sequences. Now, if you want to look at the nice sequences, that is a longer rabbit hole. We saw there's like almost 7,000. So core could be a good place to start if you're ever bored and want to research some. It's the type of thing I love talking about. So the ones that I think are coolest, at some point, we'll get an episode about that concept anyway, because whether or not it helps me to use their notes about it. because I love number sequences. But, I feel I recommend that you do your own research on places like this. And this is one of the best places to test out your own pattern and then plug it in and see if anyone else has discovered it and what else has been found about it. It's sort of it's like one of the more magical parts of the internet, that I can have a pattern I'm curious about and just type in a string of digits that I get from the first terms of my pattern, and I'm like, oh cool, someone else figured out this really cool trait about that thing I was curious about. And I've also discovered many, some of which I still need to make videos about, that are not on here. Sometime I'll learn how to submit stuff, because I have so many that I think should be on here. For example, there's a type I call threeval numbers in my last main episode, but they don't have the Throdius numbers. I'm not going to fully explain that, but if you saw the episode, note that some of those sequences, the extensions and stuff, are on here, but not a lot of the crucial ones. So, let's see. We have some... even a chat saying that. Wade was saying I should submit one. And Wade actually mentioned the number of the sequence that they submitted. And so I'm going to check that out. I feel like since you're putting it here yourself, you mean feel free to check it out. And this is the one that Wade submitted. The number of primes adjacent to the nth prime in a hexagonal spiral of positive integers. So that's interesting. You make a spiral and you count where things are near each other. It sort of has a hexagonal grid structure, and that's a pretty neat one. I'll look more into that some other time. Oh, and this is extra cool. Not only did you submit it, but have you seen somebody, or maybe you calculated these, but it looks like somebody used it in something. Or I'm not sure if this is what you're referencing or if that was referencing you. In any case, seems cool. I'll have to look more into that later. It looks sort of like related to the Ulam spiral, but hexagonal. So I do want to sometime learn how to submit some, because there's tons within main math and ones I've just discovered playing around with stuff that should be on here. If any of you have seen any sequences I've mentioned that aren't on there, feel free to submit it and just say that I found it or something. But I don't know if that's been the case yet, because most of the ones I've found myself, I did not put in an episode yet, because they're like my babies. And I'm like, I really slowly sculpt some episodes that are about like topics I really care about and really want to get right. So like things that I discovered, I might spend a year slowly making that episode. Of course, I still try to put out a main episode like every other week. I would like that to be even more frequent. Right now, it's maybe a little less frequent, but I'm trying to keep that ongoing. And sometimes they're long. The last one was 23 minutes, so it took longer. But sometimes I'm crafting a bunch at once, and I am slowly cooking with longer and longer lists of brainstorms and sometimes footage being collected, some different episodes. And one tiny clue I will say now is I spent a long time today looking for 4-leaf clovers in my yard, because I have a future episode topic that it would be really great if I had 4-leaf clover for, and I want to find it. I always wanted to find one as a kid, and I decided I'm actually just going to spend the time and I'm going to find a clover. I'm going to wait at least a month of hunting a little bit each day before I even consider giving up. And they're supposed to be surprisingly common, and people just don't look. But I cannot find one in my yard. I looked for like 2 hours, but I'm going to look elsewhere more. And then I was at the marina, just real quick, I was at the marina trying to find other patches of them, and there weren't any of the main type. There's this type called oxalis that's a clover lookalike, but I don't know if oxalis has the 4-leaf mutation as frequently, and so I'm looking for normal clovers, and it became a 3-leaf clover hunt because I couldn't even find those ones. But anyway, that hopefully will be an episode sometime. It'll come out, the episode that relates to clovers in some way. It will come out if and when I find a 4-leaf clover. It's good to have some side quests. In fact, I'll say more about that and some other side quests I'm on in another live stream. But let me jump back to the math. And We have some good comments from various stuff. Wade says people are limited to 3 submissions. I don't know if that means 3 things per person you can put ever or what, but it's good probably they have some limits. I'm not sure. Another one Wade mentions that they got approved is the sum of all prime substrings of n in base 10, including n itself, and duplicate or overlapping substrings, but not substrings with a leading 0. That's another one I'm going to have to look more into later. But anyway, the core sequences are really neat, and we might come back to the core ones in a minute, but they're not the only keyword. It's also interesting to see, for example, what combos of keywords are there? Like, I was like, is there one that's core and dumb? That would be neat. But there's not. And then I'm like, are there any that are nice but not core? And we can do that with a minus here. Oh no, the other way around, I mean, because there's tons of nice. I mean this, core but not nice. And it's like, wait, no, that's saying core and nice. Core but not nice. There's 7. This is so funny. This is core, but they say it's not nice. All of those 107 or 172 of the 179 of the core are also nice for their keyword, but these are the 7 that aren't. The all ones sequence, the positive integers. These ones, they're just like, that's not that nice. That's too boring. See, that one has a lot of notes. And the 0 function, oh no, wait, a 1 followed by only zeros. And it's the characteristic function of the empty set. Is that what they mean? Oh no, wait, that would be a set with a 0. Never mind. The characteristic function of 0, it's 0 to the n. Now this makes us assume some things within a branch of math. Anyway, interesting that makes it as a core, where it's a 1 followed by all the zeros. Shows up enough places, it's called core. This one is also the positive integers with a 0 in front. And in fact, the 0 is, they call the 0th term. So the rest, they don't even change the numbers. They just add a 0th term. I feel like those could have been one sequence, and they just say, ignore 0th term if you don't want this. But I'm not Neil Sloan or his team, and they have some method to their madness. So the 0 sequence, the negative integers, those are the ones that are core but not nice. Some of the other categories that are really neat. First, let's look at look. And let's do look ones that they also say are nice. So there's 246 that have both of those keywords. This means there's something interesting visually about it. Some of them you need to read the whole thing and figure it out, or, even find it on another source. But some of them you can see the visual thing by looking at a graph of it. And here we can see these sort of staircases on this one, and sort of strange trails like this sort when we do a plot in a different way. You can see there's different ways that we're labeling the axes. And what is the difference of us labeling that? Oh, that's just that they have the pin going up to there. Here, that's just bullets for the integers that it's at. And so that one looks kind of cool, but there are some that look way cooler. Do they have any that have core and look? Yeah, they had Pascal's triangle. The ones counting sequence, the number of ones in binary expansion of 1. And guess what? The number of ones in the binary expansion relates to that last episode I made, and it's essentially, well, the last episode I made only cares about if this is even or odd, but it's very similar to what are called odious numbers and evil numbers. Odious numbers are the ones where this is an even result. I mean, odious is odd result, and evil are even result. At first I thought those names were so random, but sometimes the linguistic connection hits you. And I was like, Oh, evil relate to even, and odious relate to odd. But let's see. Um, what other fractal? Oh, yeah. Well, so let's look at the fractal here. Can we see it here? Or do we just have to see it in like the evil numbers and odious numbers? Those are more of like a 2D fractal. Where are some of the ones that look extra weird? Some of them almost are on here because they look so neat. That one looks pretty cool. But some of them just have such weird or amazing or various sorts of looks that sometimes is even the reason they're on here. So if you like that sort, you can do keyword look. This is sort of neat. Does look fractal-ish the way it climbs up. And a lot of the ones that have look have some fractal-ish trait, whether directly or through some analysis. And Wade says, is there a way to search if the sequence sounds interesting? And there is. There's listen. Now, here's the only problem. I'm not doing this on the live stream right now because it makes you download the file. There's a button that says play as if it's play, but play or save downloaded the file of the music instead of playing it. And I don't want to be downloading a bunch of files and finding them on the computer right here during the live stream. So try listen on your own sometime later. But yeah, there are ones you can listen to that are keyword listen. And no, wait, no, sorry, it's here. Okay, yeah, keyword here. And even ones like the Fibonacci numbers have that note because they must sound pleasant in some way. Now, I actually sort of did this with the 2 Morse sequence in my last episode. I made part of the soundtrack be piano notes following it. And I liked that a lot, so I feel like I'm going to do that in more episodes. When there's a number sequence, map it out to a musical scale and put that as the soundtrack, like at least while I'm introducing the digits of it. So there's a lot of ways I could take that. Soundtracks that are the sequence. Anyway, music lessons actually will be coming really soon. I've said that before, but I'm actually planning currently with my old previous boss at a music shop I used to work, a good time for me to go into the shop to be able to film part of an episode about music there, just because they have this really cool like setup with a bunch of ukuleles and guitars and keyboards and stuff. So I want to film like the intro of the episode or something with all those instruments around. So I'm already planning that. The first one is going to be taught through piano, but applicable to many other things about major and minor and 7th chords. And a few types of 7th chord. But mostly it's about the majors and minors. And it relates to how music is a clock. Actually, many types of clock are in music. So many clocks. Clock with the notes. Clock with the whole scales. Clock with the rhythm. So many clocks in music. So, and I'm going to design. You better believe me, I'm going to make a homemade clock with the circle of fifths among other musical clocks. Let's see. I don't know why I should, honestly, that's like something I should create and sell someday, just because that's something I wish I had as a music teacher before. I wished I had, now that I think about it, a clock, 2 clocks, one that's the circle of fifths I'll explain later, and one that's just the notes, the 12 notes of the Western music scale going around. Because you can see so many patterns about like, okay, what does it mean that they're 3 half steps apart? Oh, that's going forward 3 hours on the clock. And there are 12. That makes it easier because you can just replace the numbers. There's a good amount for it. And, yeah, that's something that someone should, don't steal my idea. I'll make that someday. That's the only merchandise I'll ever make. Clocks and a card game. No, actually, nobody knows the future. Let's see. So, where were we? We were at here, which I didn't want to do because it downloaded a bunch of stuff. And we're just going to try one more look. Let's see. Were there other ones that were core? No, not that many, but nice and look. Let's do a random one here. This one apparently looks nice. Oh, that's pretty cool, yeah. Ooh, look at that. Oh, that's so cool. I imagine this continues in a fractal-like way. That's so cool. That's what they mean on some of the best ones that have look. That's what that means. That it looks really cool. So, anyway, look is good. But another one that I thought was kind of funny is dumb. An unimportant sequence. And we're going to do that in a sec, but I actually forgot one thing I maybe should have done first. They have this one called clear-cut examples of keywords. And this is pretty useful to read through if you're curious about any of them. This is like what explained them to me. And some I love. I'm not going into some of these this stream, but just to note, brief, I love those. They're so brief. It's like interesting when the sequence is brief. Either we can't calculate more of it, or some of them it just gets too big too quick, but some it's like we just don't know how to calculate the next one, like the Ramsey numbers or something. And others, it has a finite amount of terms. And then we have ones that changed. Looking up new is something I should do more often. You can see which sequences are new. The constants, I noted I don't like those as much. Core, so far so good, what I saw on the core list. Dead, they can have dead sequences. Now here we get dumb. And just to scroll through some others, we have ones like easy. Finite, that's one I really like. This is when they need to put two sequences for numerators and denominators. This is a neat one. It's like a subset of finite. When it's full, they list every term of it. And hard to calculate terms of. The ones you can hear. Less. Does it really mean it's less interesting? It doesn't mean we want fewer terms, but we want to mark the sequence as less interesting. Yeah, less means less interesting. Okay, we have to see which ones are less and dumb. Those are just the sequences they hate. But it's, if some of them make sense with like the dumb ones, it's the type of thing often that's like, oh no, not on the wiki part here. It's the type of thing where it'll be like, how many letters each number has spelled out in order in the English alphabet or something. It's just like so specific that they mean dumb in terms of how much mathematical research you could do off of it. And some of these are like primes of certain times. If you take the clock in like times, whether you just go up to 12 or go up to 24, these are all the prime times. And that should be, full one. They list every term. Beastly primes. They're just ones that have to have a 666 and has to have a 1s and 7s or something. These are alphabetical order integers in British English where they're including and, which isn't in all of the systems. I made an episode about that back in grade -1, alphabetizing the number list. But like this is what I mean by, or what they mean by dumb. Number of letters in English name for days of the week. This is going to loop these 7. But which ones are, and like even this is the type of thing some people would be like, oh, it's so deep and crazy. But yet unseen primes occurring within a first amount of digits of pi. So arbitrary and base dependent. So I'm okay with them calling some of the, I don't know if I would use the term dumb myself. It sounds kind of mean. But it's still, I can understand their logic. Now, which ones do they have as dumb and as less interesting? Is that, there's only 17 that are dumb and less interesting? They really don't like these sequences. And see, these are weird ones. A nonsense sequence. I don't know how some of these got on here. Some that just got on one day in the past, like get to stay, I guess. I don't know the system for ever kicking them out or not, but some of these are so like, let me find the worst ones. There's some are literally like, this is a puzzle my teacher gave me. What's the next number? And nobody in the comments knows. And it's like, some of those were under unknown. Yeah, look, a puzzle sequence. You're asked to find the next 3 terms. I know nothing more about it. So, the terms are so far all odd numbers, and the numbers of digits is alternately 2 and 3. So yeah, but you can't, what are you going to do after that? And find the next three terms. Nobody knows, but somehow it made it on here. This one's see comments line. They have like some from like TV shows. Like when I was a kid, I watched the TV show Lost. I bet you they have this string of numbers that was in that show. It's 8, 15, 16. Is that it? Oops. Was it this? 15, 16, 23. Yeah, look, the lost numbers. So this one, it's not actually under dumb. So whoever catalogs these watched that show, I guess. But it is under unknown because it wasn't clarified what exactly they meant. And interestingly, they're the first term. Are they? Yeah, they're the first terms of this. This could be what it is. So maybe someone calculated this looking for a possible numerical pattern behind this. Maybe that is it. Who knows? Now, what other types of ones do they have under dumb real quick? They have 11 pages of dumb. Let's just... Prime numbers prefixed with a 1. Yes, this is a dumb sequence. Prime numbers prefixed with a 1. Come on. N with the rightmost occurrence of the smallest digit of n deleted. Just like too arbitrary to be something like nice or core. It also has easy. Now, there's one category I sometimes avoid. Base. Well, let's do the ones that with them. Base means base dependent. Now, sometime I'm going to make an episode clarifying about some thoughts I've had about how base dependent and base independent is a blurry line, because you can sometimes name the patterns that you're doing in something like base 10 in a base independent formula. And so I'll clarify that line a bit more, how it's blurry more so, but there are ones that just you can tell. It's more subjective. This is more base dependent. Even if you can write it in a formula, the formula only works if it has a bunch of 10s or something. Or like there's a just very arbitrary seeming 10 in the formula. So base dependent can be turned base independent, but they're less likely going to be the sequences that deeply interest me. Hold on 1 second. Just need to check something on my phone. So let's go. What are the other keywords? And let's look at it in the clear-cut example list. So let's see. Base I was referring to. Here was cool. Less I got distracted by. That's where we were at. Less interesting really is what they mean by that. More means, but this is weird. Less means less interesting, but more means want more terms. That makes it sound like less means, or makes it sound like either more means more interesting, or less means we want fewer terms. Dang it, we have too many terms. I hate when people submit new terms to this. But anyway, that's different ways of quantifying less and more, but it's okay. They wanted all these to be like 3 or 4 letters, I think. And new is interesting because it's like, what are the new ones? Like this one was submitted March 10th of this year. That was a fortnight ago. So here we have clarifications if you want it non-negative, or sign is what they say if you can include negatives. These are ones that clarify if it looks better as a table or if that's really what it's representing. Unknown is an interesting category that contains a bunch of hits and a bunch of misses. And then there's some that are really specific. They have one like walk. Some sequences concern walks through a lattice of a specified shape, size, and or dimension. These have keyword walk. And there's 4, oh my god! There's more than 4,000 sequences that relate to walks in some way. I guess it doesn't need to be the main definition, because this one is the central binomial coefficients, which is basically the center of Pascal's triangle going down. But here, it must also be able to be interpreted as a walk of some sort. A lot of them are going to be straight up defined like that. This one's about the Ulam spiral. I wonder if the one that Wade submitted is under walk. Let's see. Anyway, back to the keywords. We have word. What interesting connections are between words and numbers in a given language? Now, some of them are kind of boring, but there are a few of these I did find interesting. Some of the ones that I like, I already read elsewhere and made a short about a while ago, but some of these are kind of cool to think about. I used to do this, it reminded me of a game I used to do as a kid. I used to do this thing, I don't remember where I learned it, but you add up the letters in a word as if A is 1, B is 2, up to Z is 26. You add up the letters in a word and you're looking for ones that equal 100. Or you could pick a different number, but 100 worked. It's like 7 to 8 letter words could work for that. But that was really challenging. It took a surprising amount of attempts sometimes, and then sometimes you'd just stumble into one. So these ones, hits and misses in like the language related facts. Also, some you might not even really know the language, but it still might give you an interesting clue, I guess. See, it's a cool way to look at it. Like if I see an outlier, that might mean like a language has a weird number under, or a weird letter under some metric. Anyway, another way, if you ever explore the OEIS yourself, another way you can explore it is, where is this? Oh, it's down here. They have, oh, it's the one they call webcam for some reason. And it like flashes some of the best sequences. Now, best, I'm guessing, is a similar list to core. But if you want to help, you can find others. Sequences needing more terms, recent additions, and so on. Like here, this is actually a great thing to have in the background of a stream if I'm ranting about something, because every 20 seconds, it'll give you a new, recently added sequence that someone put on the OEIS. But in any case, those were some of the, let's go back to core. But I might wrap it up before too long. If anyone has any questions or comments, let me know in the chat. But I may wrap up before too long. It's the type of stream that'll be about an hour. And let's first go back to core. Let's look at them this way, where we're sort of scrolling through it. Or, nah, I like the list. I had all of them. Wait, hold up. I need to... The opposite of when I check my phone is when I change something on like the desktop and stuff here. I'm going to look up OEIS core sequences because I lost my handy list of them. Principal, they name it, it's weird. They need to maybe come up with clearer terms because they have like best sequences, core sequences, and now they have the principal sequences, or I don't know if that's the same or different, but here's the core. Cool. Also, this is a cool page because that's core sequences, but it's also just the section COR of this crazy index. And like, let's look at like the index for AM. Amicable numbers. Sequences related to animals. And let's say what are ones are qua. We have Q binomials, quadratic fields. This is such a great resource. I need to just poke through this more. I need to go through every one on here sometime. What are the numbers? Yeah, so much info. Now let's get back to CO for core. Or COR. They have so many different ones that COR. Because they have several others. They have crossing. They have covering numbers. Somehow made it into COR. And correlations, sequences related to that. Sequences related to cosine of x are all under this COS section. Or no, wait, COR. Why is cosine on there? But I guess it's COR until CU is what that means. That makes sense. They don't want to list the whole range because this would be twice as long, and why. So let's go back to the cores. These are some incredible sequences. About half of them have shown up in videos of mine of some type. A lot of them even in main episodes on my main combo class channel. The ones that haven't, many are in brainstorms of episodes that I plan to have out in the future. And there's a few of them I don't know as much about that I will definitely research more after seeing them on this list, knowing that if they're along with all these classics, there must be something really important about them. And it does make me curious about some of those ones with mild variations, too. Like, why is it so applicable to have that list of the 1 followed by infinite zeros? For some reason, that was core, along with, like, the triangular numbers and stuff like that. So this is a fun thing to poke through if you ever want, but don't worry if you just like waiting until I share facts. At some point, most of the cool facts of these should end up in some of my episodes because I love number sequences. And like I said, a lot of these are already in my brainstorms for future episodes. But if you want to poke around yourself at these, see which ones look like fractals or look different, see something about a type of number you like, palindromic numbers or rep units, search your own string of digits. We could even just be like, I'm interested in a particular lucky string of digits. Is there any that goes 1, 2, 4, 8, but then, well, actually I'm doing one that I know, 16, and then 31? Whoa, there is. But here's the crazy thing. This isn't the one that people are expecting. They think I'm talking about some, actually was talking about some geometry thing, but I knew multiple would come up because I've tried this before. But there are so many sequences that start like this. There are 72, and one of them is like an extra special one. But even just searching that, so much stuff comes up. I think in a stream a while ago, we looked up some lookalike sequences. I've at least done this on my own. These are, look at this crazy lookalike sequence. It's powers of 2 up until there. That is awesome. Oh, powers of 2 up until there. Oh my God, and they're just generalized Catalan numbers of a certain type if you put a bunch of 1s before. So that's another cool thing. Seeing sequences have many ways of naming them and describing them, and sometimes you look up a sequence and you're like, am I on the wrong page? The definition they have here isn't what I'm thinking about. But then you realize, oh, whoa, they just defined it with an alternate way that does mean the thing I was thinking about. And the thing I was thinking about is one of the notes. So a lot of things like this have many interpretations. Like maybe you're looking at how many grids show up in something, or how many squares show up in some grids. Maybe you stumble into the square pyramidal numbers doing that. Then maybe you find out that's also connected to all sorts of other stuff. But if you look that up, you'd be like, huh? They don't say anything about squares and grids until you look at the notes, because they would define it in some other way. Some of them are defined even in a geometric way that isn't the most algebraic looking one. We have a question from NJ if any new core ones are being added. I'm not sure. I don't have any insider info on this, so we're going to have to just check in like a year and know there was 179 and see if there are any more in a year or something. We could also look at what could be interesting is look at the ones that are new and see which of those got other tags. Can they ever have a new and a nice? Yeah, they can have news that are nice. No news are core. If you mean, so here this is a clue toward new core ones not being added, but that just means recently there haven't been new ones. But maybe new goes away when they add certain other keywords, but you can have it in the combo we just looked at. So there's a lot of different combos that are sort of neat and fun to test out. Like, let's say I want a finite list, and let's say I don't want it to be base dependent. And let's say I want it to be, do they have a core? Well, no, they all have cores like that. Core. And let's say I want it to relate to words. That was too much. Not a core. So here, again, when spelled in English, is the smallest positive integer with exactly n letters. So when spelled in English is the smallest. So 4 is the smallest one with 4. Wait, yeah, it just doesn't start before this. It starts at 3 because there aren't 1 or 2 lettered numbers. Wait, but pi, that's a 2-lettered number, but not integers like this. And so here,
But then you get into weird questions that you have to be a little arbitrary about. If you're naming things, you're like, hey, do I include zero? What happens if I meet negatives? Wait, am I using ands when I attach things like hundreds or not? Wait a minute, do commas do anything? There's a lot of ambiguity here, but still pretty neat. I have made an episode about that a while ago, and there will be a future episode. The next language related one from me is either going to be the one I'm planning about rhymes and rhymeless words, or is going to be one related to alphabetization, which actually I went down a whole rabbit hole of alphabetization. Wait, I'm probably pronouncing that wrong. Alphabetization. I think I'm doing that wrong. It feels wrong. but alphabetizing things. Anyway, these were some things that I was playing around with earlier, and I thought you folks might enjoy joining me for the ride. The OEIS is a fun thing to come back to here and there. I do some research on it myself as well, but even just as an occasional live stream backdrop, I do like it. And, oh, there's a loud train. I swear they've gotten louder or something. But in any case, I think I'm wrapping up pretty soon. I do have a lot of things want to share, things that have been going on in my life or with videos or interesting things around the classroom or stuff. But I think I'm going to save that for its own other stream. My next live stream might be not that long from now and might be one, I mean, not tonight, but just in the next few days maybe. And it may be about the various side quests I've been doing. Don't worry, I still intend to get back to a slightly faster pace on this channel, but do make sure you've kept up with my main episodes on my main combo class channel, because those are the ones I'm most proud of anyway. This channel, though, I do still intend to catch up to a faster pace of things like shorts again. But I have been on a variety of side quests on my life as well, and I'll share some of those more in next stream. Now, it looks like we have passed an hour, and that's going to be a good excuse to wrap it up here. Those were the main things I had planned, although we could spend hours and hours coming through cool sequences. I haven't really eaten dinner, so I need to do that and have some other things to work on. But anyway, I hope you all enjoyed watching. I'll be back with the next thing will probably be a bonus video as opposed to a live stream. But there will be a bonus video pretty soon. There will also be other new things if you happen to be an awesome supporter on Patreon or YouTube memberships. So consider that if you have any extra budget. Really, really helps. Helps me not take any sponsorships currently. And so those make my videos better. So thanks to those supporters. And in any case, thank you all for watching. Stay tuned to whatever drops on both my channels next, and if you want to chat with other combo lords, there's also the Discord and the subreddit. But anyway, I love you all, and I will catch you again in the next one. If you like sequences, just triple reminder to see the linked in the description episode I put out about those on my combo class channel recently. And that's all. Time to eat some food and then